Welcome to the video tutorial for question 10 of our daily practice. Question 10 is asking us to write an equation based on either the graph or the table that we see, and later in the year we may even see a few specific coordinate points. And so we're going to focus on our steps and our key components of our graphs and our tables. A reminder for you that about 5 of our 19 questions on our daily review is about graphs, and so it's really important that you're learning the parts of the graphs and how to work with our graphs that we have. In this case, we're going to focus on a few key vocabularies, and then we'll look at a few graphs and tables and see how we can translate those into equations. The first vocabulary word is the word slope, which we also would describe as the rate of change. That's how many values or changes of y the graph makes for every change of x that we have. We've also described that it's important to recognize a positive slope and a negative slope. And so I like to think about it like a little hill and maybe a cyclist riding up the hill. If the cyclist is going up the hill from the left side to the right side, it's positive. If the cyclist is going down the hill from the left to the right, it's negative. And if the cyclist would be riding flat, the slope would actually be 0. Our other vocabulary word that we need to know is the term y-intercept, which is our starting value. That's also the value of y when x is equal to 0. And then a reminder for us that our slope-intercept form looks like this: y equals mx plus b, where m, or the value that's attached to the x, is our slope, and b, the value that's not attached to the x, is our y-intercept, or our starting value. And again, you can see how important understanding and knowing those vocabulary terms are, because we see them right there in our equations that we're going to use. Let's go ahead and start with a graph. Here is an example of a graph. The first thing that I'm going to just think about in my head is I'm just going to recognize that the slope is positive, right? If I put that bicyclist on there, that cyclist is going to be riding uphill. And it's a very steep hill, and that's another way you can start to identify key parts of our graphs or our equations. But let's go ahead and think about the components that we need. The first thing that we need is our y-intercept. Our y-intercept is the value of y when x is equal to 0. Another way to think about that is, where does our gray line cross the y-axis or our vertical line? Well, in this case, it's right there, and that's going to be what our y-intercept value is. Once we know our y-intercept, we need to find the slope, and you can always find the slope on any graph by using any 2 points of the graph and creating a growth triangle. In this case, I'm going to pick those 2 points on the graph, and I'm going to notice that my growth triangle is going to give me, I'm increasing by 5 for every 1 that I go over. And so that's my growth triangle. Now I have the components for my equation. I have my starting value, or my y-intercept, and I have my slope, or my rate of change. And so now we can write that. Now, another thing for you to think about with our slope is we can think about it like a fraction of rise over run. How much does it increase by how much it goes over? And you're going to see why thinking about it like a fraction can sometimes help us, because they may not always work out perfectly, and using rise over run will help us when they might not work perfectly. The other thing that we've also talked about is we've also said that you can really pick any 2 points on the graph in order to make our equation. But now we have our slope and we have our y-intercept, so let's go ahead and write down our equation. Y equals 5x minus 6, 5 being my slope, or my rate of change, and negative 6 is my y-intercept, or where that graph was when x was equal to 0. Now, we said just a moment ago that you could pick any 2 points to find our slope on. In this case, I could show using those 2 points. And here you're going to see that my growth triangle was 20 over 4. and that also simplifies to 5. So we know that that will work to use that growth triangle to any 2 points on our graph. That will always work for us. And let's go ahead and take a look at another example. Okay, now we see a negative slope. My cyclist is riding downhill. I'm also going to notice that that slope is a little bit less steep. That means that the number is going to be smaller than 5. Before my slope was really steep, it was 5. Now it's less steep, so I know it's going to be less than 5. And let's again talk about our key points. First thing we want to do is identify our y-intercept. That's where our line crosses the y-axis, or where y was when x was equal to 0. Next, we're going to find our slope, and this one is a little bit tricky to find our slope on. In this case, we're going to notice that I don't have perfect points to check in, and so my growth triangle is actually going to look a little bit different this time. This time I'm going to move down 2 spaces, and I moved down 2 spaces because if I only moved over 1 space, it's not going to land right on a corner. It's going to land somewhere in the middle, and I can't estimate where that is. I need to know the exact value, so we're always looking for 2 corner points. Then it's moving over 5, and remember we stated that we could write our slope as a fraction of rise over run. So now I have my slope is negative 2 over 5, and my y-intercept was 11. So now I have my equation of y equals negative 2/5 x plus 11, and this is an example here where we have a fractional slope value, which that can happen. And we just described how we could find that. We could find that by using any 2 points. Remember, we need to go right to the corners. We can't end up in the middle, or that's going to be a little bit difficult for us there. Notice that my slope was negative on this one. It's going down, so it's a rise was dropping by 2, right? So that's a negative 2 over 5, where 2/5 was my slope in this particular example. All right, let's go ahead and look at another growth triangle. Again, we said we could use any 2 points. Here, I could do a growth triangle here. That would be negative 6 over 15, and that would again simplify to negative 2/5. And a reminder, you can do this with any 2 points on the graph. Okay, any 2 points that you have on the graph, you can follow the same step. Now let's go ahead and do this from a table. So the first thing to note when we're working with our tables is we always want to make sure that our x values are increasing by a value of 1. Sometimes if they're not increasing by a value of 1, we can mess ourselves up when we're writing our equation. So let's just make sure of that, and let's go ahead and fill the rest of this table in. And these are just given values to us. And once we're in our table, we're simply going to look to identify our 2 key things, our slope and our y-intercept. I always like to start with our y-intercept because that's the value of y when x is 0, which would be 4. And then my slope is always how much my y value increases by. In this case, it's increasing by 8 each time. So my equation would simply be y equals 8x plus 4. And that would give me our value for our equation that's there. Let's go ahead and take a look at another table. In this particular table, you're going to notice that what we described in the last problem doesn't actually happen, right? I'm increasing by 3 on my x values, and so it makes it a little bit difficult to find the slope on this. And so if you ever see this happen, you might want to create an additional table, and I'm just going to basically expand this table out where I can put those missing values in there, right? So 0, 1, 2, and then put that 3 value in, and then 4, 5, and then put the 6 value in. And we can essentially fill out a new table that we can find the value that y is changing by for every one of x. So let's go ahead and look at our key pieces here. I'm going to notice that my change was happening by minus 3, but that was happening over 3x values, so that means it's going to really be changing by 1 for each x value. And essentially, I can complete that pattern that's there and make sure that my numbers match up. Once I've done that, now I'm ready to move on and find my y-intercept and find my slope. In this case, we're going to note that my slope is -1, right, not -3, because we want to know what it is per one change of x, or per one change value of x. So we would end up with y equals -1x plus 5. Now, a final note for this, as we continue this year, you may end up with specific points that are given. Maybe you're given 2 or 3 points to graph, or that you could put in the table, and you're asked to find an equation from that. The process is exactly the same. You could grab graph paper and graph it out and work backwards from the graph, or you could build the table and find those missing values that would get you back to a 0 if you weren't given a 0 value. And that would get you to how much it's changing per one of x if you weren't given that. So you may be, for example, given just something that's 2 or 3 coordinate points, and you're asked to find the equation from that. The process is exactly the same. You're just maybe looking at it from slightly different information, and just make sure that you're asking for help if you have help when we get to questions like that.